Okay, YouTube, in this video, we're going to be looking at some pretty common exercises when it comes to inverse trig functions. And basically, the thing that we want to realize is with inverse trig functions that they represent angles. And the benefit to writing them as we do, say something like this angle here, the arc sine of 1 over 2, the nice thing about that is we're absolutely already sure about two sides of a right triangle. And that is to say that this is literally saying I'm some angle in a right triangle situation where we know the opposite over hypotenuse relationship, or the y over r relationship if you're in the xy coordinate plane. But basically we know two sides of this right triangle already by writing our angles as inverse trig functions. And so what I want to do in these basically is this. First of all, sketch a triangle with that given angle. Could you show me a triangle that has this for an angle? And you notice here that I write, be sure to sketch the angle so it terminates in the indicated quadrant. So in each of these I'm going to indicate which quadrant it terminates in. But basically after that what I want to do is find the indicated trig value at that angle. So it's kind of a follow-up thing here, but this is really what I want to be able to do here. Often we're going to be asked to take, say, a trig function of an inverse trig function, but these are not inverses of one another, and so they don't cancel out completely, okay? And so we're going to actually have to go evaluate the cosine of this angle, and it's going to be most helpful if we've actually sketched the angle first. So with respect to inverse trig functions and sketching their angles, the first thing I want to say about this one here is that we know the sine of the angle comes out to be a half. That's what this angle tells us. And also, the fact is that our angles between pi halves and pi radians. So pi halves is like our 90-degree angle here, and pi is like our 180. All I know is that my angle terminates in the second quadrant. So what I want everybody to do is just basically draw on your terminal ray here. Now we know that an angle in standard position starts over here. So the interesting thing is that this is like our angle right here. But basically what we're going to be doing, as we always do, is picking a point on the terminal side and dropping down in altitude and saying, but here's our right triangle situation. So one thing that I want to do here, and it's not cheating, it is kind of like cheating, but it's not cheating. What I basically want you to understand is that this is the angle arc sine of 1/2. But really, when we look at angles, what we're really always doing is kind of looking at reference angles. And so what we say is that this angle right here, we're going to label this. This is arc sine of 1/2. And when you say, well, what the heck does that mean? It means I'm the angle that when you take the sine of me, you get a half. So the beautiful thing about writing this is essentially, remember that when we talk about, some point xy on the terminal side here, and this distance r back to the origin, essentially, we know that our sine value is y over r. And so what we're being told is that even if you did SOHCAHTOA here, opposite over hypotenuse, we know our opposite side, or our y side here, is 1. And we know our hypotenuse side here is 2, or our r value is 2. So what I'm going to do is I'm going to go ahead and go forward and say, well, then I don't know this base side. And what I want to do is really quickly here, I want to go ahead and figure this out. So we say x squared plus 1 squared equals 2 squared. So we have x squared plus 1 is 4, x squared is 3. So we get x equals plus or minus the square root of 3. Here's the deal. You do get plus or minus, but the reason why we sketch this out in the first place really is to also verify whether this should be a positive or a negative. And because we're in the second quadrant here, this point here would have to have a negative x value. So we're going to say this is the negative square root of 3, or negative the square root of 3 value. So here's the thing. This is all I wanted to do for the first part of this problem, is just go sketch this angle in the appropriate quadrant, make your right triangle, and fill in what you know from the inverse trig function. The second part of this is I actually want to go find the cosine of this angle right here. This angle right here, the inner angle. And remembering that cosine in a situation like this, as long as we know a point xy on the terminal side, and we know its distance back to the origin r, remember that cosine is x over r, or what we would say is our adjacent over hypotenuse here. So essentially we get our cosine value of this angle to come out to be adjacent, which is negative root 3, over our hypotenuse, which is 2. And so really we'd say the cosine of arc sine of a half is really negative root 3 over 2. So what I want to do is just look at a couple more of these where we're sketching the angles and then evaluating for a trig function. But on number 14 here, the reason why I want to look at this one is because it says, hey, your angle is the tangent inverse of negative root 3. And you say, okay, well, I thought this was supposed to tell me two parts of a triangle. The trick here is to just go ahead and land this over a 1. So really quickly, we're going to say, well, I'm going to sketch this angle. The angle looks like it terminates between 3 pi halves. So we have 3 pi half rotations and 2 pi. So our angle, we're just going to say some angle down here. So here's our initial side. And I get that that's the angle right there. But we're going to be looking at this inner reference angle. So I'm going to go ahead and pick a point here and drop my altitude. And we're going to say that this is the arc tan, actually we're going to write it as I've got it written up there, arc tan, or tan inverse of negative root 3. So what I want to point out here is if we put this negative root 3 over 1, then all of a sudden we know that with our tangent of an angle B being y over x, okay, or opposite over adjacent, we know that the opposite side here is negative root 3 and that the adjacent side must be 1. And the beautiful thing here is, again, we can go ahead and find r. We would say that x squared, which is our 1 squared, plus y squared, which is negative root 3, but we square it, is r squared. We get 1 plus negative root 3 squared is just a positive, and you square a square root of 3, you get a 3, and we get r squared. You can see that r is going to come out to be a plus or minus 2 here, and we say that it has to be positive. Remember, r is always positive. So with respect to what I want to find, I wanted to say, what's the sine of this angle? We can see the angle right here. The sine being y over r, or opposite over hypotenuse, we get the opposite side is negative root 3, and our hypotenuse is 2. And I do want to point this out that it is negative. But that makes reasonable sense given the fact that, the only trig function that should be positive down here in the fourth quadrant is cosine. So for this last example here, what I want to do is take a look at this last angle. We say the arc cosine of negative 3/5, where the angle is between pi halves and pi radians. So we say, well, we know our angle terminates here between pi halves and pi. So I'm going to go ahead and draw on my terminal side. Doesn't really matter where you put it here. We're just going to be making our triangle out of this. So we say, yes, here's really the angle, but the one we're looking at is this inner angle down here. So we say that this is the arc tan negative 3. Oh, it's arc cosine. My bad. And you know what? I'm going to write cosine inverse because I think I can fit that in better. But of negative 3 over 5. So remembering cosine of an angle, if you know a point on the terminal side here, is x over r. So we know our x value here is a negative 3, and our r value is a 5. And again, if you don't even remember x over r, which shame on you if you don't, but looking at this, we can just say cosine inverse is adjacent over hypotenuse. And so you can see how we're looking at that reference angle. So really what I want to do here is really quickly while we're at it, go ahead and find y. We have negative 3 squared plus y squared equals 5 squared. And so we have 9 plus y squared is 25. Therefore, the difference here is 16. And it follows that y has to be a plus or minus 4. And the thing here is this. Looking at the image, it looks like we're going to keep the positive 4. All y values are positive in the second quadrant. And so with what we got here, what we want to do is go find the secant of this angle that you see here. And so the secant, interesting. If I wanted to know the secant, I would sort of need to know the cosine first. And the beautiful thing is that this angle already kind of told us the cosine value, right? Right? The cosine value was negative 3 over 5. And so if I said, well, then what's the secant? It would be, well, I suppose, and we could even write this over here, secant of theta is r over x. And so you could see how it's just going to come out to be our r value, which is 5, over our x value, which is negative 3, or we get negative 5/3. So yeah, could I have just told you that, hey, because they're inverses and reciprocals, that this would just flip over? I say, yeah, the sooner you realize that these things are angles and it's really telling you two parts of a right triangle, the better you're going to be with your inverse trig function. Cheers.